Chapter 4, Section 1, Studying Atoms. Before we can begin and learn about how atoms or today's atomic theory came to be about, we need to know first what an atom is. It's considered to be the smallest part of an element. And we've already discussed what an element is. It's a substance that cannot be broken down into simpler substances. Now, the first influential mind that helped to create our atomic theory is Democritus. He lived roughly between 460 BC to 370 BC. And his belief was that all matter consisted of extremely small particles, and those particles could not be divided. So, for example, if you have a piece of paper, that piece of paper consists of small particles, and those cannot be divided. So, his atomic model basically looked like this. All matter is a lot of tiny particles, all put together. The next influential mind was Aristotle from 384 BC to 322 BC. He believed that there's not a limit to the number of times that something could be divided. So it could be divided infinitely many times. He also believed that there were different components that went into this. So your four elements of the earth, fire, air, and water. They also equivalent into hot, wet, cold, and dry. So different things go into different areas, and this can be divided in a number of ways. The next guy that came along, and this is several years later, so from 1766 to 1844, this is John Dalton. He believed that all matter is made up of individual particles, which have now been named atoms, and he said that the atoms themselves could not be divided. Now, there are a few things about Dalton's atomic theory. This is your image of the atom. His theory stated that, number one, all elements are composed of atoms. We agree to that. Number two, all atoms of the same element have the same mass, and atoms of different elements have different masses. That is true, but not completely true. You can have atoms of the same element with a different mass, and we'll talk about that in just a little while. He also stated that compounds contain atoms of more than one element. We also know that that is true. And last, atoms of different elements will always combine in the same way. And that is not necessarily true either. Now, the next guy that came along is J.J. Thomson. He was from 1856 to 1940, so just after John Dalton left the scene. And he provided the first evidence that atoms are made of even smaller particles. He came up with what's known as the chocolate chip ice cream model. Or in other words, you have this huge mass of some positive amount, and sporadically placed throughout that are these negative charges. A lot like vanilla ice cream with chocolate chips thrown in. But Thomson, even though he was on the right track, was not quite there yet. He didn't quite reach our modern atomic theory. So then we have Ernest Rutherford, 1871 to 1937. So roughly about the same time as Thomson, but Rutherford looked deeper. So he stated that all of an atom's positive charge is concentrated into something that we call the nucleus. So instead of just having this mass that's filled with positive charge and just having some negatives sporadically placed throughout, Rutherford now states that all of that positive charge is in the middle. So he came up with our true, what we consider to be our atomic model. So you have your nucleus, your protons are in there, your neutrons are in there, and you have your electrons orbiting around that in some kind of fashion. So your definition for the nucleus is a dense, positively charged mass that's located in the center of an atom. All right, now we're saying the nucleus is positive because it contains protons, which are positive, and neutrons, which are neutral. So overall, as a whole, it's actually positively charged. Your electrons, which are on the outside, are negative. Now, this is where we're going to stop for today. So that means when we pick up with section 2 and section 3, we'll get more in depth into today's modern atomic theory.